Hi and welcome everyone. So in this video I am going to show you how to blink an LED using STM32 microcontrollers. I am going to use the same workspace which we have created in our previous tutorial. So let me open the workspace. To program STM boards, there are basically two methods. The first one is to you can use the standard library functions or standard peripheral libraries to program that particular microcontroller. And the second method is to without using the peripheral libraries, that is directly configuring the registers of your microcontroller. So in this particular tutorial I am going to show you how to use those standard peripheral libraries and program your microcontroller. Maybe in second tutorial I will show you how to configure that particular microcontroller without using the standard library functions. Okay, so to control the output of a GPIO pin in STM boards, you need to perform two major tasks before writing your code. The first task is to configure the clock for your particular peripheral, or to enable the clock for the particular peripheral. In this case our peripheral is GPIO port A. Because I am going to use the STM32F401RE Nucleo board, which has a user LED connected at pin number A5, that is port A, pin number 5. So in this case I am going to use the GPIO port A peripheral. The first thing you need to do, you need to configure enable the particular clock for that particular peripheral. So in our case, the clock which we have to configure is AHB, that is the bus, high speed bus with maximum speed of 84 MHz. So our GPIO port is connected with this particular bus. So we have to enable this particular bus to use this particular port or particular peripheral. To do so, what we are going to do, we are going to go to GPIO library and we'll see what are the different functions available to do so. So as you can see here, the first function is enable the GPIO AHB clock using the following function. So we'll go to this function and we'll see what are the different parameters or different arguments this particular function takes. Okay, so basically this function takes two parameters. The first one is the RCC AHB1 perif. So this function, this parameter, if you want to know what it is, you can always use this documentation which is given in above this function. So here you can see what are the different parameters we can give to this particular function. So the different parameters are RCC AHB1 perif GPIO A, GPIO B, like that. There are multiple parameters. Also the second parameter is enable or disable. So we'll use this function. We'll copy this function. We'll paste in our code. And as we are going to use the port A, so we'll copy this. And the second parameter is enable or disable. So we want to enable it, so we'll write enable. Okay, so now we have set up the clock for the particular peripheral. So the next thing we need to do, we need to configure that particular port or particular pin as an output. And also there are some other parameters which you need to set. So to do so, we'll again refer to our GPIO library. So we will, as we can see, it is given GPIO initialize. We'll again go to this function. Okay, so this function also takes two parameters. So the first parameter is GPIO X, where X can be A to K for certain boards, and in our case it can be A, B, C, D or H. And the second parameter is pointer to a GPIO initialize defined structure. So the second parameter is basically a pointer to a particular structure. So let us go to that particular structure and see what is that structure. So here is our structure. That Gpio initialize function require a structure, and that structure contains multiple elements. So these are the elements of the structure. So here what we need to do, we need to define our own structure using this particular structure, or we need to define a variable to our structure. So let us copy this type definition and we'll give a name to our structure. Let me name it initialize. Okay, sorry. So what we have done, we have declared a structure with particular type definition. Now we are going to use this structure to set the elements or give the values to these elements. So the first one is to choose your particular pin. Okay, so Gpio pin. So here we are going to use the fifth pin of our Gpio port, that is port A. So again we will go to that particular header file and we'll see what are different values this particular element will take. So in this case, for Gpio pin, the values are given just below that function or structure. So these are the value which it can take. So right now we are using fifth pin. So we'll copy this, paste it here. Now suppose you want to use multiple pins for that particular port. What you can do, you can use OR operator and you can give other pins also. So right now we are using just fifth pin, so we'll leave it like this. Now the second value which we need to set, dot mode. So mode will tell you whether your pin is going to be output or input or alternative function or ADC. So we'll again go to that and we'll see what is structure it will take or what particular value it will take. So it specifies the operating mode for selected pin. This parameter can be value of reference this. So we'll go to that reference. Okay, so it can take 4 values which can be given like this: mode in, mode out, alternative function or analog mode. So as we are going to use as output, so what we'll do, we'll set it as output. You can also use this value. Now the next thing we need to set is speed. So again we'll go to that particular structure. Yeah. So here is the speed, Gpio speed, and we'll refer it to this. So again it takes 4 values: low speed, medium speed, fast or high. You can choose any speed depending on your particular microcontroller. For example, in this case the maximum speed which it can take is 84 megahertz. So we'll use a speed lesser than that. So at fast speed, as you can see, fast speed, the speed will be 50 megahertz. So we'll use this. You can use any of these 3, but don't use 4 because it will generate some what we say error or some fluctuations. So we'll use fast speed. Now the next value is output type. So again we'll go to our function, our structure, and we'll see what are the parameters it will take. So it takes 2 values, PP and OD. As you can see, Gpio O type PP or Gpio O type OD. Now PP stands for push-pull, whereas OD stands for open-drain. In case of output, controlling the output, use PP. Maybe in next tutorial I will tell you why you need to use PP. That is push-pull. So we'll use push-pull. And the last thing we need to set, Gpio PUPD. So what is PUPD? So we'll again refer to that structure and we'll go to that type definition, pull up or pull down. So we'll go through there. Okay, so there are three values which it can take. The first one is no pull, second one is pull up, and third one is pull down. So no pull, in case of no pull, if you are from electronics background, you might be knowing there are three states of a pin. The first state is high, the second is low, and the third one is floating. So if you put a no pull, it will be floating state. If you put a pull up, it will be pulled up. Like by default the value of that pin will be high, and if you are going to use pull down, it will be low by default if you are not giving any value to that particular pin. So in this case I'm going to use pull up. You can use pull down also, there is no difference. Okay, so we have given values to our particular structure elements. That is pin number 5, mode is output, speed is fast speed, output type is push pull, and we have pulled up our output pin. Now we will use that function initialize Gpio. So we'll go to again this function, that is Gpio initialize, this function, and we'll copy this. And now we'll give the values. So the first value is your port number Gpio A, and the second is the address of your structure, that is n% init Gpio. Okay, so now we have configured that particular pin as output. So now we have to control that particular pin. So to control that pin, there are two functions. Basically, to control the output of that pin, there are two functions. The first one is Gpio Set Bits, and the second one is Gpio Reset Bits. So let us go to these functions and see what are the different values it can take. Okay, so here is our function, and it also takes two values or two arguments. The first one is Gpio X, where X can be A, B, C, D, H. That is, we are going to tell which port. And the second one is the Gpio pin, which pin are of that particular port. So we'll use this function and copy this, and we'll paste it here and write Gpio port A and Gpio underscore pin underscore 5. So what we just did, we set that particular pin high, that is setting the pin. We have set the pin. Now to reset that particular pin, what we have to do, we have to reset. So here we are setting that particular bit or particular pin of our microcontroller, and here we are resetting it. Okay, so now what will happen, the program will start from here. It will enable the particular clock, it will configure the pin or bit of that particular port, and then it will set that particular bit and then reset the bit and then return 1. So what we want to do, we want to blink the LED. That means we want to infinite while loop where we can turn it on and off, on and off. So what we are going to do, we are going to use a while loop, that is while 1, and we'll put these two things inside that particular function. Okay, so now what will happen, again program will start from here and it will come here, and again in the end it will go into while loop, where it will keep on rotating, and it will rotate so fast that you will not be able to find the difference in the blinking. So what we have to do, again we have to give some delay, like set the bit, give a delay, reset the bit, give a delay. For a delay, what we'll use a very long loop, which is int I is equal to 0, I less than equal to 500,000, I plus plus. So now this is a very long loop, and what we are doing, we are wasting the time of our microcontroller. And we'll copy this function here also. So that's it for the programming part, and now we'll see whether this code is working or not. So we'll go to projects and rebuild all. Okay, so it has generated 2 errors and 1 warning. So we'll see what are the errors. Okay, identify I is undefined. Okay, so we have not declared the I. So what we'll do, we will write int I, and here also int I. And also there is one warning, statement is unreachable. So yeah, correct, we'll always be in while loop, so we'll never be reaching to return 1. So we'll delete this. This is not required actually. Now again we'll rebuild it, and yeah, so the program is working now. And now we will upload this code to our Nucleo board, which I have connected with a USB port. So to upload the code, I use ST-Link software. Also you need to download some drivers for your board. Suppose if you are using a Nucleo board or any Discovery board, or you are using a standalone debugger, you have to download particular driver. So let me choose go to connect first. We will connect our board, and we'll choose target and program and verify, and we'll browse to our particular bin file, blinky, v1 debug exe. Yeah, there is no blink file. I think I have not created the blink file. So let me go to this code and we'll check whether. Okay, so here output converter, we need to generate the output, particular output, that is bin file, binary file, and we'll give okay. Now again let me rebuild all. Yeah, so again we'll go to our ST-Link software and we'll browse STM board, blinky, v1 debug exe. And now we have a .bin file which we can directly import here, and we'll start. So it will program the microcontroller, and now we have programmed. I will press the reset button, and yep, LED is blinking. Let me show you the demo. Okay, so now let me connect the board. So as you can see, the board is connected. So this is our board, and this LED here, this blinking LED denotes that the board is now connected with the ST-Link. This is our ST-Link part here, and this is the microcontroller which acts as a debugger. It is also a STM microcontroller, and this is our main microcontroller here, F401RE. And also there are two jumpers here, which if you remove these two jumpers, you can program any microcontroller from here. There is a Jtag, this is the Jtag.
If I go closer, okay, these are the Jtag here. So this Jtag is used to program board which does not have a inbuilt ST-Link or any custom boards. So if you remove there is a two jumpers here. If you remove these two jumpers, so as you can see this LED is blinking. So our board is now connected with the computer. So what we will do, we will program this board. We'll use go target, program and verify, and our code is already here. So let me start. And as you can see, the memory is programmed in 1 second and verification okay. So now if I press the reset button of my microcontroller, let me first disconnect it. Okay, so now you can see this LED is stopped blinking. That means the board is disconnected. So now I will press the reset button. And yeah, program is started running, and here is the LED blinking. Okay, so yeah, I was not telling lie, the program works. Try it with your board and tell me whether it is working for you or not. So thank you for watching and have a great day.